Hi, this is Mrs. Rodriguez, your algebra teacher. This video is about lesson 8-2 for Algebra 2, all about adding and subtracting rational expressions. Okay, go ahead and share my presentation. All right, so let's go ahead and get started. So least common multiple of polynomials, just as with rational numbers and fractional form, to add or subtract two rational expressions that have unlike denominators, you must first find the least common denominator, okay? So the least common denominator is the least common multiple of the denominators, right? So the least common multiple of two or more numbers or polynomials, to find those, you would have to factor them, and the least common multiple contains the factor the greatest number of times it appears as a factor. Okay, so it's just trying to get you to see the similarity between adding and subtracting fractions. Normally when you add in, which is essentially what you're doing, these are fractions, right? In order to add and subtract fractions, you have to find a common denominator, okay? So the common denominator is going to be the least common multiple between the polynomials that are in the denominator, okay? All right, so let's try this. Okay, so this problem says just to find the least common multiple of each set of polynomials, okay? So first thing I would do for this is break down and figure out the factors of each of these terms here, okay? So we have 12a squared b. So you have to break down 12. So 12 is 3 times 4, and we can break down 4 to 2 times 2, right? So we have 2 times 2 times 3 times a squared times b, okay? Then for 15 times ABC, we can break down 15, and that's 3 times 5. So 3 times 5 times A times B times C. And then we have 8B cubed times C to the fourth. 8 we can break down to 2 times 4, and 4 we can break down to 2 times 2. So this would be 2 times 2 times 2 times B cubed times C to the fourth. Okay, so then we need the least common multiple, right? So we need the factors that each of these has, right? So they each, this one has two factors of 2, or two multiples of 2, no, two factors of 2, right? But this one down here has 3 factors of 2. So we would use 3 factors of 2. We want the greatest factor, right? So then we have 3 and 3 here. There's no 3 here, but since these two both have a factor of 3, we would include that, okay? And then here we have a 5. So we would also multiply by 5. And then we have a squared and a here. So a squared is our largest factor, okay? And then we have b, and b cubed. So b cubed would be our largest factor. And then we have c and c to the fourth. So c to the fourth would be our largest factor. So we multiply 2 times 2 is 4, times 2 is 8, 8 times 3 is 24, and 24 times 5 is 120. And then we have a squared times b cubed times c to the fourth. And that is as far as we can go. So our least common multiple, remember, are all of the greatest factors, okay, after we multiply them. And that would be 120 times a squared times b cubed times c to the fourth. Okay. Next problem. So now it says, same thing, find the least common multiple of each set of polynomials. Okay, so now we have 4a squared minus 12a minus 16. And we also have a cubed minus 9a squared plus 20a. Okay, so we need to factor this, right? Well, I can see that 4a squared minus 12a minus 16, they have a common factor, each of these terms, right? They have a common factor of 4 that I can factor out. So that would be a squared minus 3a minus 4. So essentially what I did was each one of these terms, I divided them by 4. Okay, that's how I got 4. I still have my 4, but now it's outside the parentheses. A squared minus 3a minus 4. Okay, and then what's inside this parentheses, I can factor that. Okay, because that is a trinomial here. So I need the factors of negative 4 that combined make negative 3. Okay, so that would be a plus 1 and a minus 4. Okay, if I had negative 4 and I added 1, then I would get negative 3. Okay, so these are my factors of this trinomial here. So I'm going to do the same thing or something similar. I'm going to factor something out. I see that they all have an a, right? They all have a factor of a. So I'm going to divide out or factor out an a, and what I'm left with is a squared minus 9a plus 20. Okay, so again, I can factor what's inside these parentheses here. So I need the factors of 20 that add up to negative 9. That would be negative 4 and negative 5. Okay, so now I can see these are my factors. And what I need to do is the greatest multiple is what I'm pulling out, right? So I have, or the greatest factors are what I'm pulling out. So I have a 4 and an a here, right? So my least common multiple would be 4a. And I have an a plus 1. So I have a plus 1. And I have a minus 4 here and here. So I'm just going to put it one time. And then over here I have a minus 5. Okay, so that is my least common multiple there. All right. And then next set of problems talks about adding, finally we're going to add and subtract rational numbers. So now that we know how to get a common denominator, okay, by finding the least common multiple, now we're going to actually add and subtract rational expressions. Okay, so first thing I like to do is rewrite these. So I have 3a squared over 16b squared minus 8x over 5a cubed times b. So notice we don't have a common denominator here, okay? So what we need to do is find the least common multiple, okay? So I can see 16b squared equals 2 to the 4th times b squared. And then 5a cubed times b is 5 times a cubed times b. So my least common multiple is going to be 2 to the 4th times 2 to the 4th times 5. And then I have a cubed, I have b and also b squared. So b squared is obviously the larger factor, so I'm going to use that one. Okay, so 2 to the 4th is equal to 16, and 16 times 5 is equal to 80. Okay, so that'd be 80 times a cubed b squared. That is going to be my least common multiple or my common denominator. Okay, so I have to multiply this fraction by, well, to go from 16 to 80, I'm multiplying by 5, and I've already got the b squared, but I don't have the a cubed. So I need to multiply this fraction by 5a cubed, and when I do that, then my denominator is 80a cubed b squared. And my numerator, I would multiply 3 times 5, that's 15. A squared times a cubed is a to the 5th power. Then over here, remember I want my denominator to be 80a cubed b squared. So 5 times 16 is 80. a cubed, I've already got that, and then b, to go from b to b squared, I would multiply by b. So I have to multiply by 16b, and when I do that, 8 times 16 is 128, and x times b, that would be bx, okay? So then, what I would need to do is subtract these terms. So I end up with 15a to the 5th minus 128 bx over my denominator, 80 cubed times b squared. And I cannot combine, these are not like terms, so that's as far as I can go. I can't simplify or anything like that. Okay. So next problem here, now we're going to factor the denominators, right? So we have x minus 1, I have x squared minus x minus 6 minus 4 over 5x plus 10. So first I'm going to rewrite this. So I have x minus 1 over, because this can be factored, right? So this is x, so the factors of negative 6 that combine to get negative 1. So that would be positive 2 and negative 3, okay? And then down here, in my denominator, I can factor out of 5, okay? That would leave me with x plus 2 in the parentheses. So, and my numerator is still 4. Okay, so now I see I have factors, my least common multiple. There's an x plus 2 in both of them. And then I have an x minus 3. And I also have this 5 in front. So that is going to be my least common multiple. So what am I going to multiply this by to get 5 times x plus 2 times x minus 3? Well, I'm just multiplying by 5. And then over here, I have the 5 and the x plus 2, but I don't have the x minus 3. So I'm multiplying by x minus 3 over x minus 3. Okay, so when I do that, I end up with 5x minus 1 over x plus 2, 5 times x plus 2, and then x minus 3. And over here, I end up with 4 times x minus 3, and then I have 5x plus 2, x minus 3. Okay, so now I'm going to subtract, okay? So first I'm going to distribute this. So this would be 5x minus 5. And this, since this is subtraction, I'm distributing that negative or minus 4. So negative 4 times x, negative 4x, negative 4 times negative 3 would be positive 12. And my numerator is still 5 times x plus 2 times x minus 3. Up here I can, in my numerator, I can combine my terms. 5x minus 4x is 1x, and negative 5 plus 12 is positive 7. And my denominator is still the same, 5, and then x plus 2 times x minus 3. Okay? And then that is my final answer. Okay? All right, so here's another example. So I have x minus 8, and then in parentheses 4x, or down in my denominator, I have 4x squared plus 21x plus 5. And I'm going to be adding this time 6, and then over 12x plus 3. All right, so first thing I'm going to do is do some factoring of my denominator. So this x minus 8 is going to stay the same. And then I need the factors of 4. So that's 4 and 1 and 2 and 2. And then the factors of 5, which is just 5 and 1. And when I multiply them, they should add up to 21. So 4 times 5 is 20, plus 1 times 1 would be 21. Okay? So when I factor this, I have 4x times x, and then I'm multiplying the 4 times 5, so that'd be over here, and then this would be a 1 over here. Okay, and then over here, I can factor out a 3, and I'm left with 4x plus 1. Okay, so now I can see for my least common multiple, they both have a factor of 4x plus 1. This one down here, we have a 3 in the front, and then up here we have this x plus 5. So all of this is going to be my least common multiple, or my common denominator, okay? So that means, what am I going to multiply this by, or what's missing from this from here? Well, the 3 is missing, so I'm going to multiply by 3. Okay, and then when I do that, I get 3 times x minus 8 in my numerator, and then I get 3 times 4x plus 1 times x plus 5 in my denominator. Over here, what's missing from this 3 times 4x plus 1 to get this? It would be the x plus 5. Okay, so then what I'm left with, my numerator is 6 times x plus 5, and my denominator is 3 times 4x plus 1 times x plus 5. Okay, then what I'm going to do is use a distributive property here. So this would be 3x minus 24. And then I would get over here, I'm adding, so this would be plus 6x plus 30. And then my denominator is the same, 3 times 4x plus 1 times x plus 5. So in my numerator, I'm going to combine my terms. So 3x plus 6x is 9x, and negative 24 plus 30 is positive 6. So my denominator stays the same. Now I notice in my numerator, 9x plus 6, I can factor out a 3. And I'm left with 3x plus 2. And then in my denominator, I have the same denominator, 4x plus 1 times x plus 5. Okay, but I notice I have a 3 in my numerator and my denominator, so I could simplify that. Okay, so I'm left with 1 times 3x plus 2, and I'm left with 1 times 4x plus 1 times x plus 5. Okay, and that would be my final answer there. Okay. All right, then we have this type of problem. We have 1 minus y over x over 1 over y plus 1 over x. Okay, so it's kind of like you have a problem up in the numerator and another one down in the denominator. Okay, so let's deal with one of these at a time. Okay, so 1 minus y over x, well, I want a common denominator. So if I need my denominator to be x, so x minus x is equal to 1. Okay, so minus y minus x. And then in my denominator, I have a denominator of y and a denominator of x. So 1y plus 1x, well, my least common multiple would be xy. So I'm multiplying this by x over x. I get x over xy. And here I'd be multiplying by y over y. And I would get y over xy. And I add it together. X plus y is x plus y. And my denominator stays the same, xy. So that would go down here. x plus y over xy. And then if I subtract it up here, I would get x minus y, and my denominator stays the same, okay? I'll just rewrite this, x plus y over xy. Okay, so now remember this line here means division, okay? So really, this problem is equivalent to x minus y over x divided by x plus y over xy, okay? And remember, when you're dealing with fractions, when you're dividing, you keep the first fraction, x minus y over x, you flip the second fraction, so this becomes xy over x plus y, and you change division to multiplication, okay? And what I'm noticing is that I can simplify at this point because I have an x here and an x here. So what I'm left with is I'm going to multiply y times x minus y, and then my denominator is x plus y. So then if I distribute that y times x is xy, and y times y is y squared. And then my denominator is x plus y. And that's my final answer. Okay, so hopefully this video was helpful to you and answered some of your questions. If you're still a little bit confused about this lesson, please call, text, email me, or stop by my office hours, and I'd be happy to help you, okay? You have a great day.